So today we're going to discuss linear regression. There are two types of regression, guys. Yung simple at saka multiple linear regression. I stand corrected. Marami pang iba, no? Hindi lang yung simple, multiple. Meron ding logistic regression, which hopefully this Wednesday ma-discuss din natin. And as I said, guys, magkakaroon tayo ng extra session on Friday to wrap up our discussion on this subject. Sana, guys, natuto kayo sa subject na to. I hope I have encouraged you enough to continue learning R. Para sa akin, I still continue learning R. Hindi natatapos eh. Ang tagal-tagal ko na. I first got to learn R year 2000 yata, 2001. When I visited NUS, National University of Singapore. Tapos doon sa library nila, sa bookstore. So whenever I visit schools, I normally go to their bookstore and see the books that they sell. So doon ko nakita yung R, no? It takes a book on R. So I got so curious, binili ko siya. Tapos that was my first introduction to R. And gulat na gulat ako kasi it was at that time, ang ginagamit ko SPSS, tapos of course Excel. And I realized that this software is freeware. Tapos ang daming features talaga. At that time, 2000 pa yun, ha? Fast forward, 2021. Ang dami ng mga packages na nakasama, no? I've been advising din sa mga thesis, no? And sa thesis natin sa FIN. And then, some of my advices, guys, we use R sa thesis nila. Just recently, yung isa ang ginamit, it was more about time series analysis ng time series with cross-sectional din. No? It was more of a panel data. Gamit na gamit namin yung R. Okay? In fact, halos hindi na sila kailangan ng nag-hire ng services ng statistician kasi sila mismo, they were able to already use R itself. No? Nakakatuwa lang kasi imagine, na-empower tayo, no? We're empowered, although we're not statisticians, hindi tayo formally, hindi naman ako statistician, but because of my self-study din and passion to learn, parang I could, quote-unquote, pose as a statistician. Although hindi nga talaga, hindi yan yung field ko. I'm more of engineering and business combined, no? But it's a matter of really your passion to learn. Okay, so I hope you have already saan tayo? So sabi ko, guys, pag nagre-regression tayo, may mga assumptions yan. So hindi tayo magmamodel ng regression tapos na. Yun na yun. Hindi ganun. Kailangan i-diagnose, magko-conduct tayo ng diagnostics. We have to see if our model follows the assumptions. Otherwise, may kailangan gawin tayo. No? May mga heuristics, may mga diagnostics na gagawin tayo, then address those. Number one assumption is that yung data dapat natin linear. Ibig sabihin, kasi sa regression, for simple regression, for example, we're modeling a dependent variable, which we normally put in the y-axis, using an independent variable or predictor variable. Okay, the x-axis. Now, when we do a scatter plot for x and y, dapat makikita natin apparent na linear yung relationship nila. Otherwise, kunyari kung it's a polynomial relationship or a quadratic relationship, it makes no sense to use a linear model. I hope you get me, guys. No? Kunyari, plinat natin, tas mukhang y is equal to x squared, yung dapat na form na gagamitin. Eh bakit natin gagamitin y is equal to mx plus b? Okay, I hope you get that, no? Kunyari yung relationship ni y at saka ni x is more on quadratic, so it makes no sense to use the linear function y is equal to mx plus b to model y using x. Okay? So pangalawa, guys, dapat yung linearity of the parameters. Ano ibig sabihin ng linearity of the parameters? Dapat, guys, yung mga coefficients natin, dapat linear din siya. Okay, we'll get to discuss this more in greater detail. Yung mga linear natin, yung mga parameters natin, yung mga ine-estimate natin Kunyari, si intercept, si slope, yung mga, particularly the slopes. Kunyari, you have 5 independent variables that we're using to predict your dependent variable. Dapat yung B1, B2, B3, B4, B5 natin, which represent your parameters, dapat linear din siya. Okay? In general, guys, bakit nga pala tayo nagre-regression? Nagre-regression tayo kasi minomodel natin yung dependent variable natin. Gusto natin ma-model siya, ma-describe siya, okay? And then also to predict. So description, explanation, explaining, and describing plus predicting. Okay? So hindi lang enough na ma-describe natin siya. Yung iba, ang talagang purpose is to predict. So how do we predict now your dependent variable y? Well, we have to use a model. How do we model? We have to make use of variables, independent variables, in order to model our response variable, our outcome variable, our dependent variable y. And as I was saying, guys, dapat yung mga assumptions natin dapat ma-meet, no? Linearity of the data, linearity of the parameters. Pangatlo, when we model, guys, tapos i-plot natin yung residuals. Yung residuals, guys, ito yung actual values minus your model values, minus your predicted value, okay, or your fitted value. Pag kinuha natin yung difference nun, that's your residual. Pag prinat natin yung residual, guys, dapat it should follow a pattern na dapat constant yung variance. Ano ibig sabihin ng constant variance? How does it look like? Okay? Sorry, hindi nag-work ng digital ko ngayon, no? Digital pad. But a constant variance, guys, wala siyang trend, hindi siya pataas, hindi siya pababa, random lang siya na it congregates around a certain value, the mean, no? Okay, wala siyang pattern, wala siyang parang fanning out, no? Kasi pag may fanning out o may trend pataas o may trend pababa, then that means that our residuals are heteroscedastic or non-constant yung variance. We want the residuals to have constant variance, a condition which we call homoscedasticity. The opposite of that is heteroscedasticity. So kapag yung error variance natin, variance of the error terms natin is heteroscedastic, ibig sabihin, hindi natin na-capture yung our model was not able to capture the variability of our dependent variable. Number 4, guys, dapat yung explanatory variables natin, hindi siya collinear. No? We don't want a situation where si x1 or independent variable 1 at saka si x2, independent variable 2 is perfectly collinear. Ang correlation nila equal to 1. Magkakaproblema tayo doon, ganun guys, no? Kapag if x1 is and x2 ang correlation nila is equal to 1, perfect collinearity, okay, we will have what we call a multi-collinearity issue. Itong mga to naman, guys, nare-resolve natin yan. So paano natin mariresolve? Kunyari yung ganung issue, pag highly correlated siya, then drop 1. You don't have to use the 2 independent variables in order to predict si y natin. Just use 1. Okay? That's one remedy that we can do, no? Number 5, guys, yung residual terms natin, yung error terms natin, dapat hindi siya autocorrelated. Anong ibig sabihin ng autocorrelated? Ang ibig sabihin ng autocorrelated, guys, yung residual of the ith observation should not be correlated to the residual of the I-1 observation. Okay? So this is more the problem of a time series. Pag cross-sectional data, guys, hindi siya issue. Kasi ang cross-sectional data, nababago-bago mo yung order niyan. It doesn't matter, guys. Wala siyang structural or inherent order. Unlike ang time series, talagang may T1 ka, T equals 1, 2, 3, 4, 5, 6. Hindi natin pwedeng bagu-baguhin, no? Okay, kunyari, we're dealing with GNP over time from 1950, kunyari. Hindi natin pwede unahin si 2011, tapos lagay natin si 2003, tapos si 1962, etc. That cannot, no can do, guys. Hindi pa pwede yun. So, ang nagkakaproblema ng autocorrelation is mga time series or panel data. No? Si cross-sectional series, walang problema. No? Walang problema ang autocorrelation kasi pag binago mo yung ordering ng data mo, mapabago na rin yung autocorrelation niya. So, of no consequence, guys, sa cross-sectional data series yung autocorrelation. And then last, guys, yung normality of the residuals. The residual errors are assumed to be normally distributed. Pag may problema tayo dyan, may remedy din tayo dyan, guys. So my point here is that when we do regression, whether it be simple or multiple regression, there are certain assumptions that have to be made. Ano bang method ang ginagamit, guys, in doing simple regression or multiple regression? We call it OLS, no? And that's called ordinary least squares. Ito yung method. Ordinary least squares. Ang ginagawa lang yan, guys, sa ordinary least squares, kukunin natin yung error terms natin, yung residuals. Paano mo makukuha yung residuals? Magmo-model ka, tapos kukunin mo yung difference ng actual value dun sa predicted value. Yung difference niya, that's your residuals. Tapos i-square natin yung residuals. And then, the model, the line of best fit, no? Okay, ang tawag doon, line of best fit, is that line where the squared residuals is at a minimum. No? Okay, minimum dapat. Okay, clear yun, guys? Yun ang magbibigay sa atin ng line of best fit, ordinary least squares. Okay, so let's have an example para mas ma-appreciate natin to. So I hope you have already installed these packages. We're going to use it as we go along. Tapos sana, guys, na-load nyo na-import nyo na yung data natin, yung wage. Okay. I have it here already, yung wage. Okay, so let's try to study first yung yung data natin. Okay, let's view, guys, let's view our data set. Okay, if we run this, view wage, you will have this. Okay, hindi ko na rin guys, kasi na-run ko na kanina. Okay, so this is our wage data frame. There are 526 observations. Okay. And there are eight variables: education, experience, tenure, race, gender, civil status, number of dependents, and hourly wage. Okay, so dito, guys, this is taken from, nakalimutan ko kung saan kinuha to, itong data na to, but this is actual data. Sa US data to, if I'm not mistaken, 1980 or 1970 yata. And it was meant to study yung hourly wage. What factors affect hourly wage sa US to? No? So these are in dollars. So education is the number of years that individual had education, elementary, college, master's. Experience is the number of years at work, and tenure is the number of years at the specific company that individual is working in now. So for example, si respondent number 1, 2 years work of experience, tenure na dun sa company 0, ibig sabihin bago lang siya dun sa company na yan. Race naman, guys, we have 3 character variables, si race, si gender, si civil status, no? Number of dependents, kung ilan yung dependents sila. Okay, and then hourly wage. Okay, then you might ask me, is it possible to use categorical variables or character variables for regression? Yes. That's what we're going to study here also. Okay, so let's go back here to our lesson. Okay, ano ba yung mga laman nito? Alam na natin kanina, names ng wage. Okay, so ito yung mga variables siya, education, civil status, etc. Okay, hindi ko na i-run si head, si tail. Okay, ito si subset lang guys. This is the first to 10 rows. Lahat ng columns, yun ibig sabihin yan, di ba? So let's take a look at the structure of wage. Okay, so makikita natin na limang quantitative variables, including our dependent variable. Okay, and then you have 3 character variables. Okay, always guys, bago ka mag-model, bago ka mag-regression, for example, understand your data first, no? Kaya nga tinitingnan natin 'to, no? Kaya nga, for example, yung class ni education, alam natin na integer siya. Class ni race is character. And then sa summary guys, makukuha natin yung mga some basic statistics. Sorry. You have your percentile 0, quartile 1, quartile 2, average, quartile 3, and then percentile 100 or maximum value. Okay, so yan yung mga 5 basic number summaries ng mga quantitative variables. Sabi natin, we can't really get the 5 number summaries sa mga qualitative or character variables. So for example, si hourly wage, okay, ito yung gusto natin pag-aralan. Ang average hourly wage, 5.9, no? 5.9. Average sa mga number of years of education is 12.6. Merong walang education, hindi nag-elementary, hindi nag-high school. Meron ding 18 years, no? So makikita natin yung distribution ng mga data natin. Of course, guys, hindi sufficient to, no? Kasi marami pang ibang descriptive statistics that you can use. So you can make use of this. So for example, dun sa finals na group work, okay, I expect you also to discuss yung mga descriptive statistics, and there are several functions in R that you can make use of. Of course, hindi rin natin titingnan kung ano yung mean, standard deviation, ano yung skew, ano yung kurtosis. I'll leave that up to you kasi that's supposed to be that was supposed to have been discussed in your previous subjects. And besides, guys, kaya namang alamin yan, kunin yung mga definition niya, no? So for example, from the psych package, we can also generate this. Okay, this is from the psych package. Kita natin si mean, si standard deviation, si median, okay, mean absolute deviation, minimum, maximum, range, which is your maximum minus minimum, skewness, guys, kurtosis, and standard error. Okay, so dito sa psych package, yung variables natin nasa row, no? Okay, so that's you can make use of that, no? And then discuss. You can also use the paste text. From the paste text package, meron silang function na stat.descriptive. Okay, so ito naman guys, yung variable nito nasa column, no? Nasa column siya, tapos yung mga nasa row are the measures. Okay, meron dito na wala dun sa wala dun sa describe function natin from psych. Wala dito yung skewness and kurtosis, wala. Okay? So this is another way. Now, si Stargazer, guys, I like this kasi maganda niya pinapakita yung sum of the statistics. So we're using the wage data set. Type is equal to text. Kailangan ilagay nyo to, guys, kasi kung wala to, hindi mapapakita yung table, no? Digits is equal to 3. Ibig sabihin yan, guys, yung ililimit niyan sa 3 decimal places yung mga output, no? So let's run this. Okay, so we can see here, guys, yung output dun sa okay, so this is the output using the Stargazer. So naka-tabular siya. tabular, which is good if you're going to copy this in Word, no? Burn types. Okay. Types kasi pwedeng ano to, no? Tingnan natin Let me check. HTML, no? Kasi pwedeng output sa HTML niya eh. Let's see. Okay, tingnan nyo guys, kapag HTML, ang ibibigay sa atin ng Stargazer, yung code, yung latex code. Okay? So this will run, guys, pag ninit natin sa HTML. Pero not here. Okay, yun ang question ni, sorry, sino yung nag-question nun? Okay. Bern, does that answer your question? Okay. Sige, thank you. Now, guys, reminder lang, pag mag-question kayo, make sure that everybody can see your question para everybody can share in your question. Okay, so let's make it text. Kasi pag hindi nyo guys ginawang text, okay, hindi aandar yung ano natin. Code ang lalabas, no? Okay. So yan, no? Na-generate yung table, guys, in a neat way. Neat way. No? Of course, pwede pang dagdagan to, no? Pwede pang dagdagan yung mga nakalagay dyan. Alright, then also sa scheme R package, guys, meron tayong scheme. Okay, okay din to. Okay, if you take a look at this. Okay, so dito, ang kagandahan ng scheme, guys, sinegregate niya yung character variable at saka yung numeric variable. So andito yung mean, standard deviation, minimum value, quartile 1, quartile 2, quartile 3, maximum value, plus a parang small plot, histogram ng data natin. Okay. Now, so with that, guys, after, for example, ang ano kayo ng regression, kailangan i-discuss yung yung mga variables, yung mga behavior niya. Tapos pag time series yan, over time titingnan nyo. So yung hourly wage ba nag-i-increase siya? Over time ba ang average ba niya nag-i-increase? So mga ganun discussion on how your behavior how your variable has behaved. Kung time series yan over the years, kung cross-sectional lang, then at one point in time lang, but there needs to be a discussion. Okay, so we're going to perform first a simple linear regression. So dito sa simple linear regression, gusto natin i-predict or explain si hourly wage based on education. So may kinalaman ba yung education daw dun sa hourly wage ng isang tao? So this is called simple linear regression kasi only one independent variable and one dependent variable. Pag multiple linear regression, you have several independent variables, and then we're trying to explain one dependent variable. And the dependent variable should be continuous, no? Dapat quantitative siya na variable. Okay, hindi integer, hindi rin well, in a sense, pwede rin integer, no? Kaso it will require another type of regression, no? Pero usually guys, pag simple or linear regression, dapat yung dependent variable natin dapat should be continuous. Okay, so first let's plot. Plot muna natin. Tinignan pala natin kanina yung yung descriptive statistics. Now, wala dyan sa inyo yan, di ba? So wala yung attached, di ba? Kasi kanina ginamit ko sa other class to. If you try to plot, guys, education hourly wage sa x-axis, sa y-axis, if you try to plot this, mag-e-error tayo, no? Subukan nyo, guys, mag-try kayo, i-attach nyo. Ano nangyari? Paki-chat nga, nag-error ba? Nag-error ba, guys? Kung hindi, wag nyo mo i-run yung attach, ha? Kung hindi nyo rin yung attach, guys, mag-e-error yan. Bakit? Kasi, hindi naman alam, wala naman tayong education or hourly wage sa mga ano natin sa data natin, di ba? Sa global environment natin. Education and hourly wage are variables coming from your wage. Okay? So you either put your wage as dollar education, wage dollar hourly wage, no? Pwede gawin natin yun. Or you can attach. Ang ibig sabihin ng attach, guys, you're signaling R na yung mga susunod na variables nanggaling yan dun sa wage data frame. Now, this is okay guys kung if you're doing a model and then yun lang yung data set na gagamitin nyo. Maganda yan kasi it's efficient. Kasi hindi mo na, every time you're going to use a particular variable, hindi mo na i-attach yung wage, then dollar, then yung variable niya. Maintindihan ni R na lahat ng mga variables na ginagamit natin is coming from the wage data frame. Okay. However, kung marami kayong data frames na ginagamit, guys, I suggest that you don't use this attach. No? Ang isang disadvantage yun, guys, kung maraming data frames kayong ginagamit, baka magkaroon ng problem, magkaroon ng confusion, especially if in the two data frames, no? Kunyari, we have data frame 1, data frame 2, tapos may pareho silang variable na age, kunyari, pagkapareho. Then baka magkaroon ng problem, guys, kasi kaninong age? So, yung pala nagre-refer ka sa data frame 2. Yung age na kasi naka-attach si data frame 1, ang tinitingnan niya yung age ng ng data frame 2, na data frame 1 pala. So, might as well not use this, okay? Especially kung maraming data frames ang ginagamit. And then besides, guys, ang isang advantage yan, although mas ano nga lang siya, pero kasi pag tinype mo naman wage, no? And then dollar. Okay, kunyari wala ito wage dollar. Yan. Pag tinype ko wage dollar, anyway guys, lalabas na naman ko ano yung mga variables ng Kita nyo ito, IntelliSense siya, no? Okay, so I can just tab that, no? Lalabas naman siya, no? Okay. So, for example, if you, okay, sige, i-attach ko muna. Pag in-attach ko siya, guys, okay, so pag rinan ko to, magra-run na siya. Okay, let's take a look at this. Okay, so sa tingin nyo, guys, nasa x-axis natin si independent variable, si hourly, si education. Nasa y natin si hourly wage. Do you think there's a linear relationship between them? Meron ba? What do you think? Is there a linear relationship? Mukhang meron naman, no? Kaso hindi siya masyadong apparent dito. Wala no? Pero pagdating dito, medyo meron naman. Kaso mukhang magkakaroon tayo yeah. Thank you, Mitch, no? Thank you, Arnel. Baka magkaroon tayo ng problema sa sa residuals kasi pag ito yung regression line natin, guys, ito, then yung iba ang lalayo na, no? Okay, so this mukhang hindi maganda yung yung magiging result ng model natin, but that's just by means of viewing it. But let's do this. Let's analyze, no? Tingnan natin. So pwede natin i-plot. So dinitouch ko na, guys, yung dinitouch natin si wage, ibig sabihin nun, hindi na si wage yung that's why here I made use of wage again, no? Okay, so if we plot this, yung una na to, guys, yung unang plot na to, okay, yun yung kanina, no? Okay, medyo dark yung siguro gamitin natin plot character 20. Okay, so here, we can see here that yung x-axis natin hanggang 15 lang. So pwede nating idagdagan ng axis, then 1 here indicates that you're working with the x-axis, and then sequence, minimum 0, maximum 20, increments of 5. So if we run this chunk, okay, so nadagdagan na yung x-axis natin, no? Any questions, guys? Any questions? Paki-chat na lang, guys, kung none. Thank you. Okay. Okay. So let's move on. Okay. You can actually, guys, you can also insert the average HR wage and average education, no? Dito sa plot natin. So let's run this whole code chunk. Okay, so ito, kita natin, di ba? Ito yung 5.9 yung average na HR wage, and then si average ni education is somewhere 12 point ano yata, 12 point something. Okay. Now, the reason why we're doing this, especially this one, yung sa hourly wage, is that this is actually fundamental to regression. Now, makakapag-regression tayo if there are independent variables that we can use in order to predict or to explain why, our dependent variable y. What if we don't have those variables? What if we don't have those independent variables? Paano natin i-predict si y? Kunyari, meron tayong data na na hourly wage, no? Pero wala tayong mga yung education, yung number of dependents, wala tayong mga just this data, hourly wage. If you're asked to predict, guys, if you're asked to predict what will be the hourly wage kunyari, of this person, syempre wala tayong basis. Okay, but the basis natin, pwede natin gamitin yung average. No? So ito, this is the average and this is 5.9. So, without using X, no? In fact, di ba, pag wala tayong X-axis, wala tayong scatter plot. We don't have the scatter plot for kung wala tayong X-axis. pwede lang tong bar plots, no? Now, sabi natin, guys, na ang magiging base na na model natin is just use the average of hourly wage. Yun lang. Okay? Okay, kaso meron tayong mga independent variables that we can use to explain our dependent variable. So we're going to use that. And yung una natin, ang gagamitin natin sa education in order to explain hourly wage. No? And then, kailangan natin malaman, guys, ano yung correlation ng education at saka ng hourly wage. Sabi ko kanina, as much as possible, gusto natin mataas yung correlation ng independent variable natin, education, and hourly wage. We want a high correlation, but not, guys, high correlation among the independent variables. So, ang correlation nito is 0.41. No? So, what does that say? It's a positive correlation. Ibig sabihin, habang tumataas yung education, tumataas din si hourly wage. Pag bumababa si education, bumababa si hourly wage. And recall from your basic stat, pag negative correlation naman, negative yung value na yan, tapos opposite yung direction ng galaw. Pag tumataas si education, bababa si hourly wage. Okay? So ito, we can actually get also the correlation of the other variables sa wage data frame natin. Kaso guys, nag-error tayo dito sa core wage kasi hindi naman natin pwedeng kunin yung correlation ng mga character variables. No? So dapat tanggalin natin to, yung race, gender, civil status, which is the 4th, the 5th, and the 6th column. So dito, ginawa natin, correlation ng wage, and then sinubset natin, lahat ng rows kasama, pero yung columns natin, negative C, 4 to 6. Tinanggal natin si column 4 up to 6. No? Remember guys, to subset, row, column. Walang nakalagay sa row, ibig sabihin lahat ng rows. Okay? So we can now run this. Okay, so this is now your correlation table. Notice that diagonals, guys, they are all 1. Ibig sabihin nun, ang correlation of a variable with itself is of course 1. So this is perfect correlation. Okay, then you have education with experience, 0.2995. Okay, si hourly wage, guys, if you take a look at this, pinaka-highly correlated, and then kay tenure. Okay, and then mababa na yung correlation niya with experience and then with number of dependents. Okay, if we compare naman guys ang isang independent variable. Okay, si education, okay, Ang pinakamataas sa correlation niya si experience. So negative correlation ni education at saka ni experience. So wala naman tayo except this one, no? Sa experience at saka sa tenure. 0.5. So, magkakaproblema ba tayo niyan kung gagamitin natin parehong predictors yan? Well, hindi naman gaano kataas ang 0.5, no? Pag sinabi natin mataas na mataas, kunyari 0.90 plus, ganyan, 0.99, halos perfectly correlated na sila. Okay, 0.95, maybe 0.90 something. Okay? Kasi pag ang problema guys, kung mataas yung correlation ng dalawang independent variables natin, there will be a problem, possibly, with multicollinearity. Ibig sabihin nun, mag-aagawan sila in trying to explain the dependent variable kasi halos pareho sila eh. No? Okay, so their capability to explain the dependent variable, we might have a problem with that. Okay, so ito tabular form, we can actually plot, no? Pwede natin magamit yung plot. Ito si performance analytics, guys. Okay, the same as above, no? Yung wage hindi pa pwede, so ang ginawa natin, wage, tinagal natin. Okay, so let's just run the second one. Okay, so ito magandang, this is a good diagram. For our correlation. Okay. So if you take a look at this one, meron tayong scatter plot sa baba. Sa diagonal, meron tayong, we have the histogram of the variable. Tapos sa taas, meron tayong correlation. Okay. Tapos yung ano pa, yung kung significant yung correlation na yun. Okay, so let's take a look, for example, at hourly wage. No? So here we have the scatter plot for hourly wage. Ito education. No? If you go here, and education, ito yung nakita natin kanina. No? Ito yung geom smooth. No? If you recall, guys, geom smooth to, hindi ito yung geom line. No? This is your regression line. Then for the other variables, experience, mukhang makikita natin guys dito yung, you can see here the correlation coefficient. No? For example, si education at saka si hourly wage, 0.41. And then, tatlong asterisk, ibig sabihin nito, this is significant to the 0.001 level. Okay? Tapos ito, 2 stars. So ano yung correlation ni hourly wage at saka ni experience? 0.11. Significant yung correlation niya. Ito naman guys, what's this? Education with tenure. So it's negative 0.056 and it's not significant. So hindi significant yung correlation ni education and tenure. So lahat ng mga walang ano dito, walang stars, okay? Hindi significant yung correlation na yan. Yung pinakamalaki guys, yung 3 stars. No? This is significant at 0.1%, 0.001. Yung number 2 guys, this is significant at 0.01. Pag isang star lang, significant at 0.05. Okay? So this is a very good way in order to describe the correlation between the variables, particularly the correlation between the dependent variable HR wage with the other variables. So significant yung correlation niya with education, 0.41. Significant din with experience, kaso mas mababa, 0.11 lang. So very weak to. Weak correlation, pero significant. Significant yung correlation niya with tenure, 0.35. Tatlo. Tapos significant yung correlation, not significant yung correlation ni hourly wage with number of dependents. So if I'm going to, for example, choose just one, no? Predictor for hourly wage, ang pinaka hindi ko pipiliin si number of dependents. Kasi walang correlation with hourly wage. Negative, pero napaka-weak, no? Hindi pa significant. Okay? So I'm not going to use number of dependents in order to predict hourly wage. Mukhang walang kinalaman yung number of dependents sa hourly wage. Unlike, for example, here, si education ang pinakamalaki, no? Na pinakamalaking correlation with hourly wage, significant, and 0.4. Okay? All right, so let's may question ba? Let me see. Okay. May question dito, Michelle. Paano daw papalakihan kung masyado maliit? Actually, sinadya yan, ano? Notice na pinalakihan nila yung mga statistically significant. Okay? Pinalakihan nila. Tingnan nyo ito, statistically significant 3 stars pero mas maliit siya kaysa dun sa 0.05. Ang suggestion ko, do not get it from here. Pwede nyo i-ano na lang, just like what I did, no? Show it in a new window, tapos you can increase, no? Or pwedeng dito nyo i-run, guys. Remember dito, pwede natin i-run dito, di ba? Tapos you can manipulate yung size ng ng plots natin. Yes, Mitch, may question dito si Mitch. Pwede ba daw i-assign yung colors to indicate? Yes, pwede guys. May ibang packages na ginagawa yan. Not in this package, not in this function, no? Sige, siguro guys, magbibigay ako ng example, but not today, no? Hindi ko kasi kabisado yung code. Pero alam ko meron, may nakita na ako guys na pwedeng baguhin yung yung colors. Okay? Pwedeng baguhin nga yung mga colors ng ng mga dots ng scatter plot. So that can be done. Okay. So we can now guys, we can now create a linear model, no? Sa R andali lang, no? Kasi we name an object called model1, use the LM function. Ito guys, linear model, and then write first your dependent variable tilde independent variable. Since simple regression lang naman to, isa lang to, no? And then identify the data. Data is equal to wage. Notice you don't put here yung data $1, no? Dito na ilalagay data is equal to wage. So if we run the first line with parentheses, open and close parentheses, i-generate sa atin yung result ng model 1. Okay, which is this one. So may value tayo ng intercept at saka ng education. Remember guys, ang simple linear regression, di ba? It will give us the equation of a line. Okay, so yung equation ng line natin, ito, y is equal to b sub 0 plus b sub 1 times x1 plus error term. Yan. So this will be the equation, guys, of a simple linear regression. Yung y natin, si hourly wage, this is the intercept, this is the slope of your predictor, which is education, and then the error term. So ito yung result niya. If you want a more complete result, guys, ito. So this is the result of this model, the summary. Okay. Okay, so what can we see here? First, kinocall yung function, LM. Yung formula daw natin, hourly wage, regression, education, data is equal to wage. And then you have here some residual statistics, no? Yung minimum residual, okay, maximum residual. Okay, dito makikita natin guys na may signal na dito na medyo, as much as possible guys, yung minimum at saka maximum gusto natin na medyo na equally spaced para yung normality na residuals natin. Ito kasi medyo malaki yung positive residuals, ibig sabihin may mga influential points or outliers tayo dun sa mga higher values, no? Okay? And then here, okay, this is the result. Estimate natin ng B null natin ito. Yung intercept natin is negative 9.049. Education natin is 0.45414. Okay, and then you have the standard error. Okay, and then you have here your t-value, t-stat, and then the probability. So yung probability, guys, ibig sabihin nito, so significant ba yung intercept natin? No, hindi siya significant. Kasi ang usual na parameter na ginagamit is 0.05. No? So, okay, let me just, ito sinulat ko kanina, sorry guys ha. Sandali. Pwede ko bang i-copy to para ano? Let me see. Para hindi nyo na masyadong, para i-copy nyo na lang sa ano natin. Okay guys, so yan. Sinat ko na lang guys, you can you can copy it. Okay. You can just copy it and insert it here. No? Yan. Okay, so what are we saying here? Ang general rule guys, when the P is low, the null must go. No? In other words, ito guys, statistical test yan. So pag statistical test, we have to come up with a conclusion about the inference, about your hypothesis. So let's start with, simulan muna natin dito guys. No? Ito, meron tayong FStat. No? Okay, value ng FStat. Meron tayong degree of freedom 1, degree of freedom 2, no? And then your p-value. Okay? So sa regression, meron tayong tinatawag na goodness or overall goodness of fit. So let's, I'll explain that. No? Ito yan guys. No? Overall goodness of fit. And that's measured through your FStat, which here in this case is 103. Okay, so paano siya kinompute? We can show R kung paano na-compute to, yung 103 na yan. Pero mas importante sa atin guys yung ano, itong p-value. Ano ibig sabihin itong p-value na to? No? Okay, so first let's take a look at this. Meron tayong, okay, okay, let me correct this. Ano? df1 is equal to your k is equal to number of predictors. df2 tanggalin ko nga to. I'm going to put it here. Okay, so in order to compute for FStat, kailangan natin dalawang degrees of freedom. Number one is number of predictors. No? So ilan ba yung predictors natin? Isa lang. Kasi si education lang naman yung independent variable natin. So kung ilan yung independent variables, no, yun ang number of predictors natin. Kunyari, if we use 4, then 4 dapat yung degree of freedom 1 natin. Degree of freedom 2 is n minus k minus 1, which is the number of observations minus number of predictors, which is your df1 minus 1. So this is your df1. Okay, and then minus 1. Okay, so we're just looking at this para naiintindihan nyo guys kung saan nanggagaling to. No? Okay, and then we have here my r squared, mamaya na yung r squared niya. Okay, ano tinetest natin dito sa FStat? So ang null hypothesis natin dyan, ang tawag natin dyan guys, overall goodness of fit test. So ang null hypothesis natin dyan is, HO1 natin is that lahat ng parameters natin, lahat ng coefficients, so beta null, which is your intercept, and beta 1, which is your slope for education, is equal to 0. So yan ang tinetest natin, no? Are they equal to 0? Okay, so what's our conclusion? What's our inference? We base it on the p-value. Sabi dito ang p-value, 2e to the negative 16. 2e to the negative 16. Okay, mali ito, no? Hindi linagay dito yung value. Okay, ang ibig sabihin negative 16, it should be 15 decimal places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then pag 16, yung 2. No? Yung 2. So that's a p-value. Okay? Ano ibig sabihin ng p-value? Na probability na totoo itong tinetest natin. So practically 0, guys. So ibig sabihin, we will reject this null hypothesis. Okay? Since p is equal to trinity decimal places ko na lang, and it's less than 0.05, then we reject the null hypothesis 1 that beta null is equal to beta 1 is equal to 0. There's strong reason, statistical reason to believe that at least one of beta null and beta 1 are values other than 0. Isa sa kanila, guys. Isa sa kanila ay non-zero. Okay, kung may isang non-zero dyan, then pwede tayong gumamit ng model, no? So that's what we call the overall goodness of fit. Okay? Clear, guys? Clear? So far, itong FSTAT natin dito. Clear ba siya? Paki-chat naman kung clear so far. Okay, strongly suggest, thank you, no? Strongly suggest ko talaga sa inyo, guys, spend some time, no? Invest in some minutes to view yung lecture, tapos i-download niyo yung Excel, tapos pwede yung sundan. Kasi pag naiintindihan niyo to sa Excel, ang dali na maintindihan sa R. No? Okay, ang rule natin, guys, when the P is low, the null must go. So since the P value here is practically 0, then we reject the null hypothesis. Okay, so that's the first statistical test, no? Okay, before we go to the next statistical test, okay, ano to? Meron tayong multiple R squared dito. Yung R squared, guys, another name for that is your coefficient of determination. Talagay ko ba yun dito? Okay, hindi ko yata nalagay. So this is called your coefficient of determination. Ano ibig sabihin ng 16.5%? Ang ibig sabihin ng 16.5% is that 16%, sulat ko dito para may instant access kayo, no? Okay, it's called your coefficient of determination. Okay, so that's your R squared. R squared siya, no? O R squared siya. Ano meaning yan, guys? Meaning, it means that 16.5% of the variability of the dependent variable HR wage can be okay. So ay linagay ko sa chat dan, guys, ha? Ano ibig sabihin ng 16.5%? So ang ibig sabihin ng 16.5%, no, na 16.5% of the variability of your dependent variable hourly wage. Bakit ng dependent variable? Kasi yun ang ine-explain natin, no? Yun ang gusto nating i-model. So 16.5% ng variability ng dependent variable natin hourly wage can be explained by education, no? So paano na yung 83.5%? Well, malamang other variables, no? So si education hanggang 16.5% lang yung kaya niyang i-explain. Then meron din tayo dito adjusted, no? Adjusted. We'll learn more about adjusted R squared. Kasi, guys, in general, pag nagdadagdag tayo ng independent variables, mas lumalaki yung R squared natin. Maganda ba kung malaki yung R squared? Yes. Theoretically, it's good. No? Kasi ibig sabihin nun, our model can explain a big chunk of the variability of our dependent variable. Okay? So 16.5%, comparing a model that has an R squared of 83.5%, as compared to 16.5%, mas maganda siyempre yung 83.5%. Kaso guys, take note, pag lagi ka naglalagay ka ng lagay ng independent variable, based on the formula of R squared, tataas ng tataas yung yung R squared, no? Tataas ng tataas yan. So kahit na hindi naman relevant yung independent variable natin, tataas ng tataas pa rin si R squared natin. So in order to penalize your model for adding more independent variables sa hindi naman relevant, ginagamit natin adjusted R squared. So for multiple linear regression, it's better to use adjusted R squared. Kasi ito parang may penalty. No? May penalty. Dagdag ka nga ng dagdag ng independent variables. Hindi naman siya significant in explaining the dependent variable. Kaya the better measure to use is your adjusted R squared. Okay. So itong degrees of freedom natin, paano natin nakuha to? Okay, so this is your DF2, no? DF2 natin, n minus k minus 1. So that's the number of observations, 526. Minus predictors, that's 1. Kasi isa lang naman yung independent variable natin. And then 1, minus 1 pa kasi this is for estimating also yung intercept. Hindi natin kasama kasi si intercept sa predictors. But since we're going to also compute for the intercept, then that reduces also your degree of freedom. Okay, so that's where you get 524. So 526 minus number of predictors, which is 1, minus 1 for your intercept, so that's 524. Okay, yung pangalawa guys, yung pangalawang test natin is itong individual test, no? Ito yung individual test natin. From this one. Ano siya? Okay, here. Ito, yung sa coefficients natin. Okay, take note guys, may probabilities dito, no? Okay, ito probability, dalawa. Kasi dalawa yung parameters natin, intercept at saka education. So, bawat predictor guys, magkakaroon siya ng estimate, no? Okay? And then, kailangan titingnan natin to kung statistically significant yung predictor natin. Pag may tatlong star guys, ito yun, no? Tatlong star means it's significant at 0.001 level. Ibig sabihin, yung p-value natin less than 0.001. Pag dalawang stars, ibig sabihin nun guys, significant at 1%, 0.01. Okay? And pag isang star, significant at 5%. Pag dot lang, significant at 10%. Okay? Usually, ang ginagamit guys, ito, 0.05. Alright, so ito guys, individually, itong parameters na to, may statistical test sila. Kung ilan yung probabilities dyan, yun din ang number ng, yun din ang number ng statistical test, ng hypothesis. So for example, ito na yung individual test of significance for the parameters. HO2, number 2, kasi ito HO1 natin to eh. Okay? So beta null is equal to 0. Saan nanggaling yan? Ito yung intercept. Ito yun. Okay? So may statistical test to. Kaso ang probability niya guys, 0.19. So hindi siya statistically significant. No? Okay? It's not statistically significant. Therefore, ang conclusion natin dito, okay, ang statistical test, beta null is equal to 0. Therefore, we fail to reject beta null is equal to 0. So there's strong statistical reason to believe that beta null could be a value equal to 0. Could be equal to 0. So may possibility yun. So kung equal to 0 siya guys, kung probably 0 siya, then it makes no sense to put it in the model. Okay? Kaso may explain ako sa inyo mamaya. Okay, so how about this guys? Yung HO3 natin. That's now for your slope. Ito yung kanina. No? Ito na yung kanina. So ang hypothesis natin dito, HO3 is that B1, itong B1 natin is equal to 0. Ano yung conclusion natin? We reject the null hypothesis that B1 is equal to 0. Okay? Since the p-value, which is this one, which is parang yung kanina din, yung 0.000002, 15 na zeros tapos 2. Since that's less than 0.001 or ang ginagamit nga natin 0.05 lang eh. That's less than 0.05, then there is this strong statistical reason to believe that your beta 1 is a value other than 0. So hindi equal to 0 tong beta 1 natin, no? Okay? So we can now write our equation, guys. Our model now is that, ewan ko ba't hindi nagra-run sa akin to? I think nagra-run sa inyo, no? Ito equation na to, guys. Huh? Nagra-run ba?
Yes po.
Okay, thank you. So ito yung equation natin, ang model natin. Ha? This is the equation for model 1. HR wage, yung ito ano to, di ba? Yung subscript, no? Is equal to 0.9049 plus 0.5541 times education plus the error term, epsilon. Okay. Ang tanong dito, bakit sinasama natin itong intercept? Understandable na isama natin si B1 kasi significant to eh. Okay? Kung hindi si education significant, dapat hindi kasama to. Pero si intercept, guys, it's always included kahit na hindi siya significant. Okay? We still use it nevertheless to predict our dependent variable even if it's not significant. Okay? So that's a practice. Ginagamit pa rin natin si intercept even if it's not significant. Okay, so again guys, ito, no? R squared. So summary mod 1 and then yung R squared, that's 16.5. Ano ibig sabihin ng 16.5? That's the 16.5% of the variability of your dependent variable hourly wage can be explained by your independent variable, which is guys, education, no? 16.5. Ito yung R squared, no? Hindi siya yung adjusted R squared. Kasi adjusted R squared natin, okay? Ano ko lang Yan, correct, no? Okay, thank you, Mitch. Okay, then there are 3 measures that we need to understand, no? Again, guys, na-explain in great detail to dun sa ano natin, sa video na sinend ko dun sa introduction, no? I hope that you will watch that. So ito, sum of the squares total, sum of the squares residual, sum of the squares explained. Okay. So, ito ginagamit natin guys para ma-compute natin yung R squared. Okay, first, sum of the squares total. What does this measure? This measures the total variability, no? If you notice guys, sum of the squares. Tinotal natin yung deviation natin. So, dito ko gagamitin kasi hindi ko makita yung ano dito eh. Hindi nagra-run yung ano ko, yung latex dito eh. Anyway, I'll just show this one, no? Okay. Now, if I copy this, copy ko to Control C, Control V. Okay. 1, 2. Okay, ano to guys? What are we computing here? This is the hourly wage. Ito yung data natin. I-minus natin sa average ng hourly wage. Okay? Di ba alam natin guys, ano ba yung mean ng hourly wage? If I run this, Control Enter, I know that the average is 5.9, di ba? Okay? So if all the points dito sa hourly wage, i-minus ko sa 5.9, what will I get? If I run this, oops, may kulang yata to. Okay, I think sumobra ako. Sumobra ako ng isa. 1, 2, 1, 2. Okay, what do you see guys? If we sum up all yung hourly wage minus the mean, okay, explain ko yan ito yung hourly wage, di ba? Hourly wage. I-minus mo, bawat isa dyan ng 5.9. Minus 5.9 bawat isa. Tapos i-sum up mo. What will you get? this amount. This is practically zero. So if I round this up, i-round ko to sa 2 decimal places. Okay, di ba zero siya? Okay, kahit 5 decimal places pa nga. If I round it to 5 decimal places, okay, zero siya. Okay, so we don't sum up yung dependent variable natin, yung data natin, minus the mean. Because you'll get zero. No? So walang sense kung bakit natin kukunin yan. Because that's the definition of the mean. Ang ibig sabihin ng mean, central tendency yan eh. That if you subtract each of the individual points dun sa average, and then if you sum that up, you'll get zero. So what we do is to come up with this measure. Kunin natin yung deviation ng hourly wage natin with the average hourly wage and then square it. Okay? So that's what we're doing here. Okay, so kinukuha natin, ano ba yung variation ng yung actual data point natin sa model natin kung wala tayong X. Ito, model lang na ginagamit lang natin si Y. Sabi nga natin kanina, di ba, wala tayong X values, wala tayong mga predictors. So gagamitin lang natin si mean, ano yung total variation nun? No? Ini-square natin yung deviation. Okay, so how about this guys? Ano naman to? Si fitted guys, this is a function to give us the predicted value. So take my word for it muna, no? Fitted mod 1, sige, i-run natin to Highlight nyo to guys. Highlight, Control Enter. Okay, so ito na guys yung mga predicted value. Okay, so ibig sabihin ng predicted value using the equation a while ago. Using itong equation na to, using this equation, okay, pag i-substitute natin dito yung education, kunyari, no? Si number 1, ang education niya, 11. Okay. Pag i-substitute natin si 11 dito, and then carry out this function, ang mangyayari, ang magiging value niya is, the value is how much, guys? Okay, thank you, Ken. Okay, what will be the value, guys, kung kinary out natin yung ano? Kasi, di ba ang equation natin, hourly wage is equal to negative 9.049 plus 5.414 times education. Yung first observation, ang education niya is 11. So, kapag pinalitan natin ng 11 to, makukuha natin yung predicted value for hourly wage. And that's equal to, ito yun guys, 5.050. I-check lang natin check natin. So, sige, no? So, this one, Control C, Control V, and then plus. This one, Control C, Control V. Times what? Ilan yung education natin? Sa first, Sa first observation. Education is 11, di ba? I'll substitute 11 here. Enter. Yan, 5.05. Yun binigay sa atin yung fitted value. Yun, no? Okay? Kuha nyo guys, na ang fitted value is your predicted value and the predicted value is your model value. Ano yung model value nyo? Ito. Ito guys, ito. Yung naano natin kanina sa regression, yung lumabas na intercept at saka yung coefficient. That's our model value. No? Okay? So ito, guys, sa pangalawa, SSR, ang kino-compare natin, yung predicted value natin at saka yung wage, no? Yung mean ng wage. Kasi 'di ba, kung wala tayong predictors, ang gagamitin natin yung mean lang, 'di ba? Eh nagkaroon tayo ng predictor. So in other words, ito yung regression natin. Ito yung improvement ng ano natin ito yung variation na we were able to explain, no? Okay? Tapos ito naman, guys, fitted minus yung actual. So ito yung residual natin, ito yung hindi na kaya ng fitted value natin. Kasi ito yung estimated value natin, pero ito yung actual value natin. So that's now the residual. That's now the okay, so my question dito, ano yung fitted? Yung fitted, yung predicted, no? So fitted, predicted, forecasted, pare-pareho lang yan. Okay? Pag sinabi natin fitted, yun yung magiging value based on the model. Ano ba yung model natin? Ito. Di ba rinan natin yung model? Yung line of best fit. So ito yun, no? Ito. Ito yung intercept na sinama natin kahit na hindi significant yung ano yan, plus yung coefficient ng education. Okay? Tapos rinan natin siya. Okay? Yeah, why siya? Pag sinabi natin, MIGS, pag sinabi natin predicted value natin ng minomodel natin. Sino ba yung minomodel natin? Diba si hourly wage, no? So ang predicted value natin is the model that we get using the equation. Okay? So ito yon, no? Kasi ito yung equation natin, negative 0.9049 plus 0.541 times education. Eh si unang respondent, guys, ang education niya 11. So i-substitute natin yan, tapos i-solve mo yan, ang makukuha mo 5.05. Okay, ano ibig sabihin yan? So sa model natin, a person with 11 years of education, kasi yun lang naman ginagamit muna natin. Okay? Thank you, Migs. So kung 11 years of education mo, ang i-predict ko based on our model is that your hourly wage is 5.05. Kaso nga lang, guys, ano ba yung actual? 3.10 ito. Okay? Ang predicted natin 5.05. So, eksakto ba? Tama? Hindi. May residual tayo. So, ang residual natin will be 3.10 yung actual minus yung predicted 5.05. Okay? So, makikita natin yan in a while. Okay? So, take note, guys, pag may model tayo, magkakaroon tayo ng predicted value at saka residual. Bakit tayo magkakaroon ng ganun? Kasi may actual value tayo, no? Okay? May model tayo where we can get your predicted value. Tapos, kung i-compare natin si actual value at saka si predicted value, meron tayong residual. Okay, so, okay, guys, tuloy ko na to kasi gusto kong mapareho tayo ng dun sa kabilang section. So, ito naman, guys, yung sum of the squares of your error terms, no? Okay, so let's run this. Let's run this together and I'll explain. Okay. So ito, guys, yung computed na variance natin nung pag ang model natin yung ano lang, yung mean lang, no? Hindi natin ginamit si X. So ang total variability natin ni hourly wage is 7160. Nung ginamit natin si education, okay? Ito yung na-explain ni education 1180. Okay? Ito yung SSR. So ano natitira? SSE, guys. SSE. Ito hindi kayang i-explain ni education. Okay? So 7160 minus 1180, 5980 yun. Okay? So in other words, guys, si SST, ito, si SST is simply SSR plus SSE. Ito yung explained, yung SSR. Ito yung unexplained, SSE. Variability, variation na na-explain natin, variability na hindi natin na-explain. Okay? So si R squared, guys, is simply the ratio of your explained over the total. Kaya nga nung rinan natin to, guys, yun, 0.165. Kinompare natin dito sa summary natin kanina, parehong-pareho, no? Okay? So I hope that's clear, guys. Okay, let me just continue on a bit kasi magta-time na. Okay, now JTools package has a very good way to put into table yung model 1 natin, no? So if we run this, if you run that, guys, ito makukuha natin. So you see, it's a nice way to present your, pwede natin makopya sa Word to. Tapos kung Word ang gagamitin nyo or HTML, maganda yung lumalabas na format, no? Observation 526, naka-define kung sino si hourly, si dependent variable, OLS linear regression. Ito yung sinasabi natin, FSTAT, degree of freedom 1, degree of freedom 2. Ito yung value ni FSTAT. Probability is 0.00. No? R squared, 0.16. Adjusted R squared, 0.16. Hindi na nga lang niya nalagay yung 3 decimal places. And then here's your intercept, estimated value, standard error, t-value, and p. Okay, so it's a good way to present your, unlike yung kanina, guys, di ba? Kanina yung model natin medyo, pag kinopya mo sa Word yan, hindi maganda yung kakalabasan. Okay? So ito maganda, naka-tabular form siya. Okay? So it's almost time, guys. Okay, tapos ito na lang ha. Si module 1 guys, si model 1, ito yung mga laman yan, no? Ayan. Si coefficients. So ano lang, kung gusto natin makuha si coefficients, ito yan. Ayan. Ito yung coefficients natin, si intercept at saka si education. Residuals guys. Oh, ito na guys, yung residuals, no? Ito na yung actual value minus predicted value. Di ba yung predicted value natin sa una is 5.5, tapos ang actual niya 3 point something. Ito yung error natin, no? Yun. Minus. Okay, tapos ito na yung fitted. Ito yung fitted value natin, fitted dot values. Ito yung kanina, no? Okay, so you can do it this way, model 1, then dollar fitted dot values, or fitted model 1. Confidence interval, okay? Ito yung 95% confidence interval. Explain na natin to next meeting. And then si Akaiki, no? At saka si Bayesian. Okay, explain ko next meeting to. No? So, just this last one guys, para pareho lang tayo dito sa kabilang section. Now, to write your output in APA format, ganito, no? A simple regression was used to predict the hourly wage from the number of years of education, EDUC. The number of years education explained a significant amount in the variance of hourly wage. Ito, binigay natin F, DF1, DF2, value, P is equal to, and then R squared is equal to, adjusted R squared is equal to, the regression coefficient, ito yung 541, 95% confidence interval, indicated that an increase in 1 year in education corresponded on the average to an increase in hourly wage of $0.5254. Okay, so it's already time guys. So next meeting, may I request you to please continue. Tingnan nyo to guys, kung anong ginagawa nito. Ito yung ano lang natin, yung model lang. Yan yung regression line natin. No? Tapos, next meeting, tapusin natin to guys. Tapusin natin itong lahat. Tapos we'll move on to another expansion of our regression model. Sa dulo guys, makikita natin dito, ito yung stepwise regression, which we're going to discuss next meeting. All right? So thank you so much guys. I'll see you. Kung magpapacheck na attendance,